thermal trip circuit breaker operates by tripping when the current exceeds its designed thermal rating for a prolonged period. Its response time is slow to overcurrents, typically several minutes or hours. The purpose of a thermal trip circuit breaker is to protect against overloads and prolonged current flows that can damage wiring and equipment. Thermal trip circuit breakers are suitable for protecting resistive loads such as heaters and motors that draw constant or slowly changing current. An inverse time circuit breaker operates by tripping with an inverse time characteristic, meaning the tripping time decreases as the overcurrent increases. The response time is fast to high overcurrents and slower to moderate overcurrents. The purpose of an inverse time circuit breaker is to protect against both short circuits and overloads. The faster response at high overcurrents helps to limit fault damage, while the slower response at moderate overcurrents allows temporary overloads such as motor starting. Inverse time circuit breakers are suitable for protecting inductive loads such as motors and transformers that draw high inrush currents or may experience transient overloads. The key differences between a thermal trip circuit breaker and an inverse time circuit breaker are firstly the tripping mechanism, secondly the response time, thirdly the protection type, and fourthly the suitable loads. Firstly, regarding the tripping mechanism, a thermal trip circuit breaker uses a thermal overload, while an inverse time circuit breaker uses an inverse time mechanism. Secondly, regarding the response time, a thermal trip circuit breaker has a slow response, while an inverse time circuit breaker's response varies with the overcurrent. Thirdly, regarding the protection type, a thermal trip circuit breaker protects against overloads, while an inverse time circuit breaker protects against overloads and short circuits. Fourthly, regarding suitable loads, a thermal trip circuit breaker is suitable for resistive loads, while an inverse time circuit breaker is suitable for inductive and resistive loads. Thermal trip circuit breakers are designed to protect electrical circuits from overloads. They operate on the principle of thermal expansion. When an excessive current flows through the circuit breaker, a bimetallic strip inside heats up and bends. If the current persists long enough, the strip bends sufficiently to trigger a tripping mechanism, opening the circuit and stopping the flow of electricity. The response time of a thermal trip circuit breaker is relatively slow, meaning it takes a certain amount of time for the bimetallic strip to heat up and bend enough to trip the breaker. This makes thermal trip circuit breakers suitable for protecting against sustained overloads, such as those caused by excessive current draw from appliances or equipment. These breakers are often used in applications where short duration overloads are expected, but prolonged overloads could cause damage. Inverse time circuit breakers, on the other hand, are designed to protect against both overloads and short circuits. They operate on the principle of inverse time characteristics, meaning that the tripping time is inversely proportional to the magnitude of the overcurrent. In other words, the higher the overcurrent, the faster the breaker will trip. Inverse time circuit breakers typically use a combination of thermal and magnetic tripping mechanisms. The thermal mechanism provides protection against sustained overloads, similar to thermal trip circuit breakers. However, the magnetic mechanism provides instantaneous protection against short circuits. When a short circuit occurs, a large current flows through the circuit breaker, creating a strong magnetic field that triggers the tripping mechanism, opening the circuit immediately. The inverse time characteristic of these breakers allows them to handle temporary overloads, such as those caused by motor starting, without tripping unnecessarily. At the same time, they provide fast protection against short circuits, which can cause severe damage if not interrupted quickly. The choice between thermal trip and inverse time circuit breakers depends on the specific application and the type of loads being protected. Thermal trip circuit breakers are generally preferred for protecting resistive loads, such as heaters, lighting circuits, and small appliances, where sustained overloads are the primary concern. Inverse time circuit breakers are typically used for protecting inductive loads, such as motors, transformers, and large appliances, where both overloads and short circuits are potential hazards. In summary, thermal trip circuit breakers provide slow response protection against sustained overloads, while inverse time circuit breakers offer fast response protection against both overloads and short circuits. The selection of the appropriate type of circuit breaker is crucial for ensuring the safety and reliability of electrical systems. When choosing a circuit breaker, it's also important to consider its ampacity rating, which is the maximum amount of current it can safely carry without tripping. The ampacity rating should be selected based on the load requirements of the circuit being protected, as well as the ampacity of the wiring. Additionally, it's important to ensure that the circuit breaker is properly installed and maintained, following all applicable electrical codes and safety standards. Regular inspection and testing of circuit breakers can help identify potential problems and ensure that they are functioning properly.